We're going to talk about ray diagrams for lenses now, and they're very, very similar to that we have for mirrors. So when light passes through a lens, it's bent twice. It's bent at the first boundary between the air and the lens, and then at the second boundary between the lens and the air again. We tend to simplify this when we are drawing ray diagrams for lenses. So we just say that it bends at the lens. A convex lens, also known as a converging lens, any light that comes in that is incident on that lens will converge at the focal point. So what convex lenses do is focus light from a large distance away, all to one point. That distance is called, the focal distance is called f, and we'll use that in calculations in lessons to come. Now a concave lens, like a convex lens, will bend the light when it goes through, but because of the geometry of the surfaces, you get refraction moving with the incoming light moving away from that central axis, so it's also known as a diverging lens. And if we look to where that that dotted line goes back here, this is actually where the focus, or the virtual focus of that lens is. I'll just draw in some of these other things, and let's see, they all appear as if they're coming from the focus if the incident ray is parallel to that central axis. There we go. All right, so they move away from the focal point. Here's our convex lens again. It, of course, has two focal points, one on each side. So just some of the standard rays that we can draw for convex lenses to allow you to figure out where images will be for convex lenses and then for concave lenses. So your object over here, a candle in this case, hits the lens and refracts, not reflects, I was about to say reflect, refracts and heads through the focus. Or any ray that goes through the center will go through without changing its direction, because it bends as much when it comes in and it bends back that amount when it comes out, so it essentially heads straight through the lens. And if, of course, if it comes through the focus on the side that the object is on, it goes out as if it were parallel. And you can see here, this is where our image is going to appear, and because those light rays actually converge, they actually go through the same point, they don't just appear to come from a point, that image is real, which means it can be projected onto a screen, and it's inverted. It's upside down. I'm very sorry, these yellow things here, this says, what does this say? F, and there's another F. If we have an incoming ray, so this is for circumstances when the object is between the focus and the lens itself. So we have to consider a ray coming through the focus, as if it were coming through the focus, from the top of the object up to where the lens is. And notice I'm still using this axis for the lens. I'm just drawing it down here, but we're assuming the lens goes all the way up there, and it refracts out parallel. So if the ray is appearing, or would have come from the focus, or is coming from an angle that lines up with the focus there, it goes out parallel. Again, if it goes in parallel, it refracts out through the focus, and if it goes through the center of the lens, it comes out unchanged. And you can see where those three different rays, or you could just use two of them, you don't have to use all three, where they appear to come from is where your image is. So in this case, it's obviously upright and it's magnified, it's enlarged, but it's also virtual. Those rays don't actually come from that point. They just appear to come from that point. And this is exactly how a convex lens is used as a magnifying glass. We put the object closer to the lens itself than the focus, so in between here, and it enlarges the image. So the standard rays we use for a concave lens, we have an object, we send in a parallel ray, and it bends away from the central axis as if it were coming from the focus on the same side there as the object. Same for a concave lens as for a convex lens. The ray coming through the center will just keep on going undeflected or unrefracted. And you can see already that where those two rays appear to meet is where the image will be. We can also draw a third one where it comes in as if it were going towards the other focus. It refracts and it goes out parallel, and we can see that that one also agrees with the other two. So that's ray diagrams for concave lenses and convex lenses. We'll get to more practice of those in class.